Hello, good morning to all the participants. Hello, good morning to all the participants.
Good morning. Good morning.
Good morning, ma'am.
Expert lecture. The expert lecture is on embedded system. So our today's expert is Mr. Naresh Prajapat. He is presently working in the Pentair Noida-based company as a senior project lead. He has also a specialization on the Internet of Things. Naresh has more than 14 years of experience in product development, embedded system, firmware designing, software and security, compliance certification, electrical machine design and manufacturing. Naresh Prajapat is always eager to learn new things and challenging things. Naresh has completed his diploma in electrical engineering in year 2007 and joined the SR group. But to pursue his dreams, to work something innovative, he left the job in 4 months. He has completed his BTech degree in Electronic Instrumentation and Control Engineering Department with honors from Engineering College Bikaner itself, from the Rajasthan Technical University, Kota, in the year 2010, while working with various organizations along with his studies. Naresh Prajapat has worked with various organizations within India and UK. He worked in the core team in a startup, naming the learning space. The space is recognized by FRD, Government of India, and works to fill gap between industry requirements and academic learning in the course. So I would like to welcome Prajapat on please join us.
Madam, I think network is some network problem is there.
So shall we wait for a few more minutes, sir?
Network. Am I audible?
I would like to invite Aulraj Chaudhary, sir, to say a few words about the
Amul sir audible.
and embedded
Pooja
systems.
ma'am have issue with the voice.
Yeah.
Okay,
Dr. Momin, it's I think network issue anyway. I think my network is perfect.
Okay, sir. Your network is perfect.
Okay. So the second session we are going for this is prototyping with embedded system, and we are having our expert Naresh Kumar with us. We would be talking about that prototyping. Earlier session was more focused on the basics, what different type of embedded system, what is the hardware requirements and all. Now in this second session, we are going for how we can develop prototyping systems with embedded systems. So I hand over to Naresh Kumar. Naresh, are you there?
Yeah, I'm here, and I can hear you. So,
Yes.
thank you.
Yes, please. You can start.
Right. So, good morning, everyone. Thanks, Pooja, and thanks, Rahul, for the brief about today's session. So, today's session is about embedded prototyping. Let me share my screen so that we can start with the session. For the session, I am just asking everyone to please keep their microphones on the mute. And in case anyone wanted to ask any questions, they can either unmute that time particularly, or just raise hands, or maybe pass their questions into the chat windows. So I'm sharing my screen. I hope it is visible. My screen is visible to everyone. So today's session is about the prototyping embedded systems. So we will learn about the prototyping of the embedded system. We will take
It
one
is not
example.
yet, sir. If it is not yet visible.
It is not visible. Let me check again. Now, if anybody can confirm, is it visible?
No, sir. Sir, screen is not visible.
Yeah, I'm sharing the screen. Just give me a minute, okay?
I think Naresh, it's visible. Let's start now.
Now?
Yes.
Yeah, sure. Sorry for the interruptions. Some technical problem with the. Okay, so am I audible now? I hope. Everyone can see my screen? Okay.
Yes, perfectly.
Okay, sure. Thanks for confirming. So, sorry for the interruption and keep all of you waiting for a few minutes. So we can start now. So this is about the prototyping the embedded systems. So in earlier previous session, you all go through the components, the different parts of the embedded system, and now we are going through the prototyping. During this session, we will go take one example, and the example will be we will take a simple example just to go through all the terms and taking all the things into the some consideration. So take the example into the real life, like how we will design. If we wanted to design the same example, then how we will, what are the components we were going to take. So what it includes, this complete slides will include the product requirement capturing, which we will call as an PRD. In short, if I say that its term is said, it is, we will say in our next slides, it will be referred as a PRD document. And secondly, the hardware parts. Third, the firmware or software parts. Firmware term, I think that you all are aware about the firmware term. These are the specifically softwares which are written for the interaction with the hardware, basically. And the ecosystem requirement for the firmware designing. What are the requirements? Why we needed any system which is ecosystem ready? And the documentation which are needed for the different parts or different phases of the prototyping or the design phase or design development and then release processes. All these documentations are there. And so first of all, we will understand that what is why we will need a right approach where before starting the designing of any of the embedded system. So because there are a lot of different companies out there, which we can say that increase in OEM, that is original equipment manufacturer are there. If I name some of them, then if I wanted to design something like RF communication part we wanted to design, then there are a lot of companies like I can get the data from chips from the TI, I can get chips from the ST microelectronics, I can get the chips from the microchip. There are different vendors. So, and these are coming with a very ready product. What is nearly just we need to write down the application part and which application fit which part, that is not very much differentiated. And there are a lot of very closely parts are there. That is the same thing.
Naresh.
Yeah.
Hello, Naresh.
Yeah,
I think you can off your camera so that the bandwidth will save and voice will be clear.
Okay, thanks for sure.
Okay.
Okay, thanks. So, right. So I will, sorry for that part. So
Please increase the volume of your mic.
Okay, is it now good? Better?
Yeah, better, Naresh. Continue, please.
Okay, sure. So there are a lot different service provider or manufacturers or OEM manufacturers are there which provide the actual chips and what we needed for the embedded system designing. So these are also that is also sometime when the experience the different vaccines that these are confusing or these might be misleading parts are also available there. So these are that is why we needed a right approach and we need to understand why. We need to design and understand each and every part of the before we jump into the proto and then pilot and then subsequent manufacturing parts. And there are a number of possible solutions available for same application. Like if I wanted to have some application, then there are different, not any certain thing that can not be done only the one way, but there are different ways with which it can be solved. That is why the right approach is needed, not only specifically for the hardware, but software and all the other things which are parts of the embedded system completely. So we will understand, we need to understand what are the components of the embedded system before we select the right approach for our requirements. So moving next, I'm going to take, like I've said, that I'm going to take an example and then problem statement for complete this understanding of these components. So I'm going to take a very simple example, the example of the problem of water over.
The voices again.
Naresh, you are not audible.
No. Yes. Still some. Am I audible? Dr.
Yes.
Mohammed?
Yes, you are audible, sir.
Yeah, yes. I think there is some problem from Naresh sir setup.
Am I audible?
Yeah, next one is what it is. So we include the product requirement category, which we will call it as PRD, the hardware, software part.
Your voice is breaking, sir. Voice.
System requirement and documentation.
You stop your video.
Is it good now?
You please stop your video.
Yeah, I have stopped my video. Hold on. Now, the pressure head which is needed, and this will also impact the communication technology which we need to use to communicate between the whatever technology we will use to detect the overflow. So that is also a significant parameter for this. So this is the example basically we will take, and the different components we will discuss in further slides as well. And next we will need to understand that what is the product requirement for the problem. So this is the problem statement and the example we will take, and the product requirement of PRD for the problem we can understand, and basic, if we understand it in a large scale, then we understand that an intelligent system need to be developed or need to be designed, which system shall be detected tank full condition basically. So whenever the overhead tank full, it should detect it and stop the motor which is installed at the ground level. So must not get wasted. So this is the basic requirement. So this is how it can be understood as a product basically. So we will keep different steps for this product design and prototype preparation with further slide. So PRD, if we will go to the slide, which is understanding that the PRD, how we will capture the PRD. So I already told that the PRD is for the product requirement documentation. So product requirement needs to be captured in right format. That is highly needed, because in case we missed to capture the requirement proper format, then may not be the communication will not be the proper for the different aspect or different team peoples. So there is one small thing which is always says that if we were not able to communicate the things or requirement properly, then design may not be fulfill the requirement which is understood. So that is a common part. So that is why it is needed to be captured properly. So every requirement should be named one design page, or each and every requirement should be named as in some significant number. So which requirement, how much requirements are there? Like if I say that the water level detection needs to be done, so it is a requirement of that product. So these are the components. And secondly, motor needs to be stopped. So some control need to be there, which will be designed to have some kind of relay should be there, some kind of a controller need to be there. So all these requirements lead to the implementation. That is why it needs to be captured in the very right form. And the product portfolio team analyzes the problem statement and find out the potential requirement of the product. If I say that the product portfolio team, so there are teams which need to be identified the potential and longevity of the product particularly. So when the one organization or one team launches a product, so that need to be early analyzed that what is the requirement. If the product is capable to sell into the market, is there any requirement basically for this particular product? And marketing team provide input for feature requirement with competitors or potential competitors. So marketing team provide if there are already the similar kind of products are there, or if there will be very soon any product can be replaced, or how competitive it should be there, or if there is already a product is there, we can design in some way which can create our USP as well. So all the requirements and brainstorm to find the robust design specification and test condition. So when we say that the robust design, so the robust design basically is to identify that how we can create a product without understanding, when we are brainstorming for the robust design or any brainstorm about it. So they do not think any part about the cost of the product. They will eliminate the cost criteria while the robust design specification on understanding brainstorming part. And then when all these things are done, then when that is designed and understood, then they come into the cost part, and that cost part always came like the quality and compromising part, that what feature we will definitely need it and what feature we need to eliminate to meet it within that cost criteria. So when we understand the robust design, definitely which earlier need to be eliminated and further need to be came again into the picture, which is the cost criteria. For our example, which have taken the water overhead water tank case. So for that, like PRD, could we have the water level detection? That is also a requirement. Like water level need to be detected. Motor control, as I said, the motor control need to be there because we need to switch on the motor, we need to switch off the motor. All these things need to be there. And communication between the overhead tank to the motor, which is usually installed at the ground level. So there should be any communication between both of the parts, like how we will detect, how the product will detect the water level. Basically, it could be wired, it could be wireless, anything could be there. There may not be any communication. There only be the sensor could be there, which can be wired only. All these things came into the communication part. Or power requirement of the product. So these came different approaches, like product power requirement need to be understood properly. There could be some specifications or some compliance as well for the product power requirement. Cost will definitely be a part. We can understand it is in BOM cost particularly. So BOM is used for the bill of material cost. So that will be so considered like what is our targeted goal for BOM cost, BOM cost. And development cost definitely that will be significant in case of some organization which is startup organization or something which is not already have all the part in-house. Like I say that in software development, there could be some of the things which we will see in further slides as well, that the software are having some licenses or all these things are there, which are very significant costs. So that will also came into the development cost or PRD part. Like if we are choosing some controller and which is specifically using have any open ID or an open platform to develop, then definitely development costs need to be checked with the PRD as well. UX will also be the part of the PRD, which is the UX is used for the user experience. And nowadays it is very significant for each and every product. And you can see that if I take a very simple example here, that usually when we see some of the products which are we take an example, Apple products. So Apple products teaches the world that how the UX should be taken, because when we see the Apple product, it is very nicely colored. Color combinations are very good. So it is user experience is very, very good and delighting the customer kind of thing. So these are the user experiences basically. So then that is why it is needed and added part of the PRD all the time. And last one is the USP. In case we have some USP, unique selling point, which we can add for the PRD, which can be for future for the selling point for the product, that should be into the PRD basically. So now I'm moving forward with the design team. So when the PRD will be completed, then it will be shared with the teams. Like it is created with all the team people together. All the inputs will be there, but then it's a one draft early or the initial draft will be created, and then it will be shared with the design team. And design team will provide their inputs particularly for different criteria with checking its feasibility, and if there is any other there is any other products with the organization already there, so the similarity or any common part which can be used. So all these are there. So design team then started working on the initial draft of the PRD. And PRD design architect group provide their further inputs. Like there could be when the robust design and all these things are there, then there could be endless opportunity can be written into document. But the feasibility and what are the possibilities that can be incorporated. That is going for the design team input. Design team plans a POC. The plan POC is the proof of concept basically. So the POC results will be provided as input to same PRD document. So these all are provided, like which are done and how it is done, or which part, or how it is designed basically. Final requirements are freezes with marketing, portfolio, and design teams. So this is the part when it came like where when design team done the POC, small POC part, or done the feasibility or provide their inputs, and then the requirement are freezes because it is checked that what can be feasible, what can be done, and the marketing team provide their input, portfolio team have also done that part. So all the requirements need to be freezed now so that it can be developed further, and all the stakeholders can start working on that particular part. So the requirement need to be freezed at some place. So this is the place where requirement need to be freezed. At this stage, requirement need to be freezed. There are always options to add further requirement in case of the product highly needed. But in flow, if I say that it need to be again come from, if any new requirement will be added, it have to come from all these levels, and up to here the requirement will be freezed if any new requirement also came into the picture. But from here the further development will be started. So design input, for example, if I take the example which we have taken, for example, so that example, water head tank example, in case wireless communication, controller board will require. So design team can provide this input that in case wireless communication, 2 controller boards will be required, definitely, which will increase cost. So BOM cost will be increased. And the second that design team can provide the input, that is the wireless communication has maximum range from 10 to 50 meters with no or heavy obstacles. So that will also came from the design team that whatever the technology, wireless technology we use, definitely it came with some limitations that it do not have endless communication distance. It will have only 10 to 50 meter distance, or with different technologies, and with heavy metal objects, it will not communicate with if there is a nearby any heavy metal objects are there. And in case of wireless communication not available in this particular product, if I say that design example product, so in case of wireless communication not available, product functionality will be failed, because if wireless communication is there and that is not working, then definitely motor is not going to stop. Either it will provide the signal, and signal is not reaching to the motor level. So definitely the product functionality will be failed. Okay. Okay. Yes. Mhm. I don't think you do. Okay, sorry for everyone. So in case of wireless communication, so product design will be also failed. So in case there is anything failed with that wireless communication, So the product will fail. So this is something which is the failure mode of the product. So that should also be included and provided design input. And separate power supply will be needed for wireless module at overhead tank side. So in case we will design or that it will design with the two wireless communication, then the separate power supply will be needed for the wireless module at overhead tank. There can be something like the battery operated or all these things, but this is also came from the design input that these are the requirements added requirements due to this particular requirement. So these are hardware requirements will be added. Separate wires will be needed in case wired sensors are used. So separate line of wires will be need to be implemented or need to be installed at the premise. So that will also add the product. Maybe the product will not do. Maybe looks like a separate installation and dedicated installation need to be done. So all these things will be design input for this particular example which we are taking. So these will be incorporated in this document. So and then it will be further move forward. So in parallel, all these I'm saying that activities I'm taking in series all these activities, but definitely the activities are going in parallel. Like when the design team provide the input and the requirement freezes, and at the same time, then all the requirements are done. So all the other team are working in parallel or providing the input. So for the verification process, I'm just taking that how that part is now done. Like the design team has provided inputs, they have starting designing that. So how they will design the PCB? So designing the PCB is a separate part, but how they will verify that part? So there could be different parts for the hardware. Particularly, if I'm taking this for the hardware process for now. So we are taking the hardware designing and verification part for now. So hardware team design PCBs, but before the deployment, PCBs can be tested with the simulation method. So designs shall be verified and tested before PCB and deployment. Different test and verification methods are used, and at design level, simulation techniques are used, which help designers to identify problems at design level. So hardware designers can use simulation tools like EICE or LTM, etc. Okay, and firmware simulation tools are also, and which can be used for the hardware as well. Sometimes the MATLAB, Excel, ID specifics are also there. So all these things are the verification processes which can be used for different parts. In parallel to design team, as I say that I am taking the team, I am explaining this sequentially, but in parallel to design team PRD, it is shared with the validation team as well. So the PRD is shared with the validation team. So validation team that frees the PRD, which is the requirement is freezed or finalized. So the validation team, what it will do? Validation team, if I say that is the QA team basically. So validation team write down test cases to test the white box and black box activity for integrated parts of the product. Validation team get reference from hardware and firmware unit test plans to identify different test conditions for the final product. Test cases are executed manually or automated as per the need. So what it includes that the QA team, what the QA team's responsibilities are, that when the product is requirement is freezes, then they can start thinking that how they will test it and started designing the test cases against the requirement. So if there is any particular requirement that is designed in hardware and the firmware, then a product team QA team need to be ensured with some specific test cases, which can be the positive test cases and this can be negative test cases. Positive test cases are which is against the requirement meet. But the negative test cases are the test cases which need to be done to where the particular product or particular feature will be failed into that particular part. Okay, so if I say in particularly, if example, that overhead water tank, so the positive test case would be like when the water tank flow up completely, then the motor should stop. So this is the positive test case. And there could be something like if it is not running, and what is the endless time if a motor is not getting filled for 1 hour or 2 hours. So there could be some leakage in the pipe, or there could be something which can be into the negative test cases, that if it is not getting filled within that 1 hour or 2 hours, then the motor will endlessly start running or it will stop. So these are the small things which need to be included, which can be part of the QA team to ensure that products should not fail in any case. So these are the things which we discussed. But for the hardware, when it is getting designed, so now it came to the design part. So QA is working on their part. They will test it. The team started working, and their processes is defined. All these things are captured. So now it came to the hardware designing part. So how the hardware will be designed? There could be separate parts. Hardware selection will be one major criteria. So there could be controller processor selection, have some specific reason to select some controllers. Availability, that is a very needed one. So need to be considered, because there is one term industry uses, that is that TINA cases should not be there. So there is no alternate part. So we should not do any part in design which is only one supplier is there, only very few suppliers are there, or very specific supplier are there. So that can lead to product failure sometime, because if company rises the price very significantly, okay, or in case the company will stop manufacturing that particular part, or they are not supplier is not available. So that will also lead us to the failure of our products. So there should not be any part used which is only the one supplier, or there is not a very common part is not there. So that is also need to be considered for the hardware particularly. Actuators are there, so there are also parts which actuators we need to use. We will go through one by one into that, which are the actuators, sensors are there. Interface with controllers, like which are the GPIO, ADC, DAC we needed. DAC is just the reverse of the ADC. Communication interfaces like I2C, SPI, UART, or these are the chip level interfaces. There could be some interfaces which could be wireless as well. So sensors could be there. These are the input. Sensors are usually input devices like push buttons, switches, potentiometers, thermistors, like 10K thermistors are there for temperature sensing, microphones, infrared, ultrasonic sensors, which are basically, if I take an example for infrared and ultrasonic, these are used for sometime level sensing, or sometime proximity sensing. And the pressure transducers are under the pressure basically. There could be actuators which the hardware team need to be incorporate. Like these are basically output from the controller. Like LEDs need to display some state of the device, like it is faulty or it is working good, it is working now, what part it is running now. All these things can be displayed easily with the LEDs. If I take some small example for the LED, basically where you see, so usually if you say that water filters, they do not have an actual display. There are LEDs are only there. So it is showing something. If you go to your home's RO, then there are 2 LEDs or 3 LEDs are there, which is show that it is working okay, it is green there. And if it's red, then need to be changed the filters. So these are also used for displaying information. LCD displays are there, which is in mobile phones and other products. Buzzers could be there. Valves and switches. Valves are used for the flow controlling, but switches are for basically electricity valves, if I can say it similarly. So valves are basically flow switches. When the hardware selection is done, or two hardware selection finalize some of the hardware, the proto or POC, there will be some methodology. So at very early stages, the proto methodology or POC is used. So breadboards are basically at very early stage. It is used just to proof of concept that it is working and this circuitry can be done. So breadboards are easy and most common way to start with POC or prototype. When things are working good, it's good to solder the products. But before soldering, if someone wants to check these with the breadboards, it is a good option. Scale up up the proto. When things are good and we are soldering it, all the things, and then it is good to scale up the product. So for the scaling up, usually PCBs are manufactured. When things are, say, I wanted to make a large scale, then we use the PCBs. PCBs are easy to manufacture, basically. It is not easy in the process. If I say, if I wanted to have it quickly to develop it, it is not a very quick process. We need to have the proper PCB manufacturer there. When we have done all these parts, and it is very, very good to have the PCBs because these are easy to manufacture. If we wanted to large scale or wanted to develop piece per day, then it is very good to have the manufactured PCB. It has very, very small footprint for the same number of components. If I install all the components on breadboard, usually breadboard needed to have the PTH component. But into PCB, we can have the same component with the SMT. If I say it's SMT, so SMT is surface mounted devices. SMD devices. And PTH is pin through hole devices. So these are also small in size, so that can be also very good to have. These are basically two things which methodology is used. And for the controller selection criteria, I'm not displaying very much here, but there is small info is needed here before to select the control to understand what criteria could be there. I think in the last session we have understand a lot of things about this controller selection, but this is very small intro. Wanted to have here. That is it is because it is very crucial task, with particularly when we are prototyping this. So in the very early slide, we understand that there could be a lot of manufacturers there and suppliers are there. Similar parts are available. That is why controller selection is very crucial task stage. So we need to understand the RAM size, our requirement of our application. We need to understand the flash size. So flash size basically what is the size of our application will be there. So in case of the communication method, the RAM size is definitely going to increase. So that these are also the things need to be considered when we design the particular application. So that is why the controller selection is very crucial task. And processor speed is also need to be checked. If in case we needed some wireless communication, then these have some significant things which came with the some processor. And architecture. So architecture is something which is having a lot of things need to be clubbed. So in case we wanted to have an open source platform kind of things to maintain that cost criteria which we take into the PRD document for the development perspective. So that also be taken care here during the controller session. But because in case we do not select the proper architecture and that lead to proprietary kind of products, then it will definitely going to lead us to increase that cost at the PRD. So that these are also the criteria we need to check with the controller selection. Power modes, definitely in case device is mostly the low power mode, then power modes should be there, checked particularly for the controller that how much power modes are there and what is the minimum power mode and what is the possibilities to communication or other parts of that power mode of the controller, so that we can run it onto the very low power mode in case of some battery operated devices particularly. And peripheral requirement, if we needed some ADC, some specific ADC of a high resolution or all these things, then need to be checked with the peripherals. And in case some needed, GPIOs are not a very concerned areas usually because GPIOs are there. But in case we needed a large number of GPIOs, then it need to be checked, particularly that control directly we need to control it, or we can use some mux in between. And connectivity option is definitely there. What communication or what connectivity needed. In case wireless communication, then we do not have an option to choose without wireless any kind of communication part. So connectivity option definitely need to be there with the controller selection criteria. So earlier we understand that there could be different methods for the hardware designing, hardware selection criteria, different verification processes. But for the particular hardware verification, if we go through that hardware schematics are prepared with any of the selected tools. Schematics have to be verified in simulation for all the functionalities. And PCB will be prepared and simulation testing is done for various certification criteria of product. In case product be certified against some of the particular requirement, like C certification need to be there for the European countries, or some other part like there could be radiative emission, spurious tests are there, and radiative susceptibility tests for hardware are there. So all these came as a requirement for particular hardware. So all these things can be done with the two steps. Like one, all these things can be done with the simulation, and when the simulation things are in good shape, then the material will be manufactured. And when the actual hardware comes, then these are tested against these criteria which are required for the particular meeting one certificate. So hardware verification is done in two stages, like one for the simulation, same as we discussed earlier, that LT Spice or other tools can be used. Usually the tools have the feasibility to, with whatever the tool we choose to develop the hardware, the same tool is available to have the simulation testing as well. So when the hardware is sent, the hardware is tested, simulated, tested, and then sent for the manufacturing. PCB came with the manufacturer, the PCB is done, all the components are placed, and then came to the hardware designer or developer, and then it needs to be tested, because first time we have created PCB for particular hardware, so it needs to be powered up particularly and checked for all the components. Okay. Okay. So when it will came, then we need to be powered up it, and hardware is prepared, then needs to be checked for first time power up, power levels, voltage levels are checked on the various test points. All components are tested separately for working conditions. I think someone, if I request everyone to keep the mic on, please. Okay, so all the components are tested separately for working condition. PCB is checked for all the interfaces are working, and communication modules are need to be tested for impedance levels as well. Okay, and for this particular example, if I say that PCBs get manufactured, then we need to test for the water level sensors are working. These are separate component. Motor control is working for switch connect, disconnect functionality. Communication is working. In case of wireless module design, maximum wire length need to be in case wired sensor connection. So these are one particular connection is also there, like maximum wire length in case of wired sensor. In case of wired sensor, there are some particular example also that there should not be an interface with any power supply or other high voltage devices. That also need to be checked, and we have a consideration of design, but need to be tested here as well. So short circuit tests are done for sensors particularly. Because that sensors are installed at at the upper side, or maybe the coming out from the controller. So that short circuit test needs to be done. Power supply reversal test should be performed as per design. If in case we have designed it that we can reverse the power supply in case of DC supply, then it should also be tested. So all these are the basic tests which need to be done. Okay, and one test which is usually not come as very common, which is the power interruption test. That should be tested first level, because that causes sometimes transient are there, and hardware get faulty. It came to the some developer, and that is not really known that where it is get faulted. Where maybe power interruption may causes the issue. And 115 kV human model test shall be performed, which is usually when the human touches any of the components. So these components are static discharge sensitive, and that is the product. So these also need to be tested. RS, RE, spurious test, which are specific to some certifications that need to be checked with the actual setups. These are the very costly setups, so these need to be tested separately with the lab of the RF lab. For firmware, if I say that we are moving forward with the firmware, so there could be development environment. Some particularly, if we take the consideration that open source are there, proprietary development environments are there. ID selection is a very crucial criteria. OS selection is also need to be checked that which OS we choose. We can have the OS particularly RTOS, or we can have the some infinite loop conditions. So open source, it is free to download and use. A lot of forums available to support. It is flexible. In future, we can easily modify that. Can start with a very small. We can start with a very small in terms of cost and in terms of the part as well. And it is future ready usually. And the same thing, which is a flexibility. Proprietary. So what is the game? There are no free lunches. Yes, everyone say that there are no free lunches. So either pay for the software or develop cost it. So in case of we use the open source, definitely we need to have some developer which is very much know-how with the particular that open source, or there could be something some time consuming. Both the things, it is going to cost us. Quality will be assured with a proprietary. Dedicated support will be available in case we face any issue. The dedicated support will be provided. Time to market can be achieved. We can plan the things in advance. So project goal can be easily planned. So that is why time to market can be achieved. Some interface or algorithms are not available with open source. There could be some proprietary algorithms which we can have with the proprietary software only. For the selection, I must say that there are a lot of IDs are out there in market. MPLab have their own ID. For the microchip products, Proteus, Arduino softwares have the ID, PC Spice, MATLAB, LabVIEW, Visual Studio, Keel, ARM. For the ARM, they have different ID. For the normal different controllers, they have different ID. I missed TI here, so TI also there. So there are different IDs are there. IAR is one of them. So these are come from the pricing and what controller we have selected. OS selection. OS selection could be, we can use the bare metal, we can have the free RTOS, BIOS, Zephyr, Safe RTOS, TI RTOS, VXWorks, MQX. So some of them are free and some of these are the paid versions. So these come with some cost for the using the software for development. Then we come to that when we have developed the firmware with all these criteria and whatever we choose, then we need to come to the testing. How the firmware testing will be done. Various parts of firmware are unit tested for its functionality with the simulation. So for simulation, we can use the Excel sheet, we can use the MATLAB, we can use the other ID specific tool as well. So simulation can be tested. In case any calculation design methodology is implemented or any algorithm is designed, it can be simulated for math modeling with MATLAB and other tools as well. For example, FFT can be math model for the MATLAB. IAR filter, simple averaging, running average, PID controller design, there's a specific design. These all can be done for the simulation part. And the firmware integration, this is a very crucial part basically, because when first time firmware is getting integrated with hardware and running with hardware, then it needs to be done with some steps so that we can, that can be have the minimum time consuming for this particular part, because some most of the time the firmware and hardware when meet the first time, then it is facing the issues. So firmware is integrated one module at a time on hardware. It should be integrated one module at a time. Every module of hardware is checked with firmware integration separately before working all together. In some complex systems, separate firmware is managed for first level hardware. In case we have large RTOS systems, then separate hardware testing firmwares are also built just to test the functionality part, and whatever the drivers have written, it is perfectly okay for the and hardware. And firmware is unit tested for every module separately. Unit testing is done on functional level, where inputs are known to developer and tested to expected output only. There is no need to unit testing is performed by firmware developer only. Firmware developer will done the unit testing, and there is no need to store the failure result, because there could be 10 or 1,000, maybe whatever the number of test cases that need to be executed, but the result should be the passed, and that only is stored, and that which is used by the QA team further. So what is the intention? Intention of the firmware unit testing is to ensure the developer has gone through all the software with required inputs and there shall be no unexpected results are there. So that is only the intention. Intention is not that it will work perfectly fine, but at least what is written that has gone through by the developer and written against the requirement only. So that is the intention, and that can be used by the QA team further. And the product testing. Then when the product is hardware ready, hardware tested, then firmware is ready, firmware is tested, firmware is integrated with the hardware, it is unit tested, and then all the things are go to the QA team for the product testing. When the product is ready by hardware and firmware team, then it is presented with the validation of QA team for product level testing. A formal release will hardware and firmware version need to be created with release document with and suitable software used to manage system history of release. Like example, Jira or Agile, all these systems are used to release the particular version of the firmware and hardware. So against which hardware the firmware should be tested. So and the document like the release document need to be shared with the QA team. So why it is needed? Product tested against requirement because the product is tested against the requirement sheet and test cases written by the QA team. In case of any deviation or it must be reported to system to relate functional and team person. So that is why that should be came with some process so that if there is a problem or bug reported, then it should be shared back. So that is why it should be in a system related. So that is all the process need to be followed so that we can have each and we can maintain that part like firmware, which hardware and which firmware is showing the issue and how it will be fixed. Bugs may have different level while reporting actions shall be taken accordingly. So, for example, I say that the bug can be trivial level, which can be fixed, and later stage risk level bugs could be there, high risk level bugs could be there, and some bug or some problem could be the like blocker level where the QA team cannot move further and testing immediately need to have to be stopped because it is a blocker level issue and they cannot move forward, and then it need to be immediately fixed and new release need to be provided. And when there's a problem, the product rework need to be done. In case any bug or deviation is reported, concerned team take the action. Bug is fixed in hardware or firmware, whatever level it is needed, and needed to be provided to QA team with fresh release note and version. So version need to be changed definitely because that is only the significant criteria with which it can be tested again. So every bug have to be verified only against the release note. So in case there are 5 bugs are reported and if one bug is a blocker level and blocker level bug is immediately fixed. So that only that bug can be will be provided in the release note that this bug is really fixed and all other 4 bugs may be on the working criteria. So the bugs can be checked against only on the release note basis. As a product release, when QA team found product satisfactory against all requirement criteria, it will release product to production. And the production team will prepare a separate production document with all the feature set, required documents, and provide it to the production team. So this is how it will move from the requirement capturing to complete product release. So how we will capture the requirement to PRD particular format. Then we came hardware development. We have the hardware verification into simulation, hardware unit testing, firmware development, firmware unit testing, integrate all these things together and then release to the QA team, and QA team will release to the product into the production level, and production will definitely going to release to the market. So these are all the criteria for the and all the components which need to be and process need to be followed for the embedded system prototyping or how we will prototype an embedded system for the maybe as which is the future ready for the production. This is all about this part. In case any question regarding this, I already requested, so you can now ask the questions as needed. Yeah, open for the question.
Yeah. It was slightly difficult time initially. Yes, please, if you have any questions, because there should be more interactive session.
Good afternoon, sir.
Yes. Yeah, Dr. Momin.
Once we have a prototype by using, let's say, Arduino or Raspberry, right? But when you go for production and the actual delivery, or we can say the full-fledged product in market, the cost is one of the issues. For example, this is the case what we have studied just now, water level controller. For water level controller, if you are using the Raspberry and all Arduino, which cost much higher. Instead, if you have a small, what you can say, optimal processor. So how we can convert our design to the optimal one by replacing that prototype board with the optimal processor, embedded processor, basically.
Right.
Now, sir, you hear me?
Understand your question. Yeah, sure. Sir, I hear you. Yeah, I hear you. So, thank you. So I understand that the concern point is that in case we have prototyped it with some large processors, and then we wanted to change it to the some level where it is need to be manufactured at the mass level, or the price need to be in control. So in this case, if I say that the Raspberry is not in control, it is a processor specifically. So in that case, when we choose the Raspberry, that is the design need to be done very significant changes. But in case the application is small and you are using the Arduino particularly, then there is a possibility that that can be changed to some controller, which is embedded controllers very differently. So with the Raspberry, it is not directly possible, because the application is written for the OS level directly and run as an application. But with the Arduino processors, if I say that if in case we choose the application with the some layering architecture, particularly where the layers, driver layers are different from the application layer, then it is very easy to change the product for any of the controller. And using basically, if you say that embedded controller, most of the embedded controller applications are written into the C language. So if the application part only written for that particular C language, that it is very easy. So that layering need to be done particularly. So the layering, if I say that there should be the hardware layer should be different from the application layer. So that layering needs to be maintained from very early phase. So then when we have proof of concept has been done, then only the application part can be moved on any of the controllers directly.
Okay. So
But
do you know
sorry, it can.
Yes,
Mhm.
it is, I got
Sorry.
it. Sir, in India,
Yeah.
do you know the commercially service provider for the SoC system on chip? Or they again go to the China, means they take the order in India and again also to the China. Do you have our in India this kind of an to have a SoC system on chip at
Right.
mass level?
Right. This is for now, it is a bit challenging for India, because we do not have directly manufacturing with the mass level. But there are some of the manufacturers, I do not know lot of names here, but if you go to some of the companies there into the India, like Tarang are there, Tarang modules came as an SoC, and some of the other as of now these days. There are some lot of projects are running which are SoCs are manufactured not on the mass level as of now. If I say for the mass level, if you say that is only the Tarang modules which I can for the SoC chip, particularly in Indian manufacture. So, but other products are in place, and when the development and these things will be came into the picture, then mass manufacturing will not be in very much issues. But the issue is that the development ecosystem needs to be created, and when the development ecosystem will be there, and they're easy to develop the things will be there, and application can be very easy to design that, then mass manufacturing can be done. That will be in a part. Basically, these are the situation which is not basically that mass manufacture will be there and then the requirement will be done. But when we start using these chips, which are coming as a development board from the Indian manufacturers, and some IITs are also working on that part, so then Indian SOCs should be available. So when we start using and creating the application, and forums need to be updated with the developers from India, different developers are going to publish their things, and how easy it is to start a small application on that SOCs, then definitely the mass volume will be available. As of now, mass volume directly is not available for any these SOCs directly. I think I hope I answered that part.
Thank you. Thank you.
Yeah, thank you.
Dr. Momin, I think there are two issues here. One is SOC, that is system on chip, that is a part of VLSI design. And
Yes,
here we are using that once that VLSI Fab Lab, the output is like IC or microcontroller.
Yeah.
So that microcontroller is to be used. So what we can do here is like this microcontroller 328P. That is being used in this microcontroller Arduino development board. So that can be used to develop that board. That 328P that is available for 30 rupees hardly.
Yeah.
That we have done in our that we have done in our lab also. That we have a PCB manufacturing PCB fabrication machine. And you can develop that small board and put some electronic component like capacitor and oscillator, 8 megahertz oscillator or 16 megahertz oscillator. That is that supports.
But ultimately, what are the board you have developed? Just now you have mentioned the same thing we are doing. So I want whole stuff to be on one chip. That is also possible.
No, that is you can do something, but you have to support that also. Like some driver PCB or driver circuit you need to have.
PCB design, just now I mentioned the component, everything can be just put up before that company, and that can put everything in a single chip. That is at a very cost, maybe 10 to 12 rupees per chip if you put in the mass. That is what they, but they put the order to the China, and again that becomes copied. So many other issues. But in India, still it is a problem.
Yeah, see, the problem is the cost of a chip maybe 5 rupees or 10 rupees or 10 rupees or 12 rupees. That is because of its mass production. And if you have an application for a particular IC, like you can make 1 million or 2 million, 20 million ICs are required, then definitely that can be made. And this fabrication lab, IC Fab Lab is a $1 billion investment, so it's not very easy. However, Government of India is trying to, because that economy can be only boosted up only and only with these electronic control systems are adopted, or electronic controlling mechanism is adopted by industry. Then only we can have some low cost production and fast production systems. So this is understood by Government of India, and they are coming with some good policies for Fab Lab and all that type of industry to initiate here. Anyway, we have another question from Dr. S.K. Masood. Do we have any platform for design and prototyping which an electronics guy can collaborate and get the product developed? So I could not exactly understand, but we are like a platform. Like if we are from electronics or even maybe non-electronics, See, product has a different aspects. There is machining also required. There is some electronics also required. There is some design person like who can understand the psyche of the public. What should be the color? What should be the shape? Everybody has to be there, and all these things are to be integrated. So it's not possible that an electronic guy himself can produce some products, or a mechanical engineer can produce some product, or some designer and master of design who has done master of design from IITs or somewhere, he can develop it. It's not possible. It's an integrated effort, and we have to collaborate. So if you are from non-electronics, definitely you have to also collaborate. I am from electronics or instrumentation background. I also have to collaborate. And at present point of time, we don't have that exact information where officially you can collaborate. But yes, in academic institution, like yesterday we had Professor Harlal Singh from MNIT, National Institute of Technology, Jaipur. And we are here in Bikaner. So we can make a team, and this particular workshop or this particular FDP is having one of its important objective that we should be able to collaborate with each other. You are a master in machining work, I am master in electronics work, let's say, whatever the PCB I can design, whatever the PCB I can manufacture. So all these things I have facility with me. So we have to definitely collaborate in that sense. And the product is always, see, I would like to tell you that I am taking classes. I am from electronic instrumentation background, and I am taking classes of second year mechanical. And I am teaching them electronic circuits. I am teaching them digital electronics. So it is very, very important to understand whether you are from mechanical or you are from electronics, that as of date logic, which was earlier being inculcated with mechanical technology, it has to be only and only with electronics technology. Like you can see that float valve. Naresh was taking that example of water overflow, water controller. So a float valve, you can recall that float valve, that's a 200 rupee system. There is a ball, and once you reach up to the particular level, this will automatically close that valve, and water flow will be stopped. So that has to be replaced with electronic system. So it is not the domain, electronic domain. These are the requirement of the society. And we have some skills, like I have some skill in circuit designing or some microcontroller systems. You have some finishing or some electrical person from electrical background. He know what the motor, what should be the motor. Like I can give you an example. Some of student in my lab, they said that, sir, we will make a robot. I said, okay, fine. Yes, go ahead. That's a very good project. So the students took some motors and the microcontrollers, and they literally made that, and that was working on the paper. But when they actually fabricated, they cut some aluminum sheets also, they connected each and everything. And finally, when they started that robot, it was not able to lift its hand because that motor was not able to give that required torque. So that boy asked me, sir, torque kahan se seekhe, where I can learn about torque? You go in mechanical, or you have to refer to some mechanical literature. So this is a common integrated activity. We have to collaborate. So Professor Masood, I think this is very clear, and we will definitely collaborate. We'll keep on communicating. We have a good facility. We'll show you that how we developed that Arduino microcontroller board. You have seen that. That's available for 300, 400 rupees. We taken a 328P processor microcontroller, and we integrated with some oscillator circuitry and all these. And that cost was hardly 80 rupees, 90 rupees. So we can provide such type of development board to all the students. They can make their different projects. So this is all we are trying to do. So we can exchange such type of information with you also, and you may be having some strength in some particular different area. Like Dr. Naveen, he is from industrial background, so definitely he can be a very good advantage for all of us. Dr.
Yes, sir.
Naveen,
Yes. Yes.
Dr. Naveen has a very good question, sir. What is the selection of sensors? What are the criteria? Yes, this is very beautiful question, and I would ask Naresh to address this question. Naresh.
Yeah, thanks. Thank you. This is really a needed question, that what are the criteria to select the sensors basically. So as Rahul said, now that there is a collaborative approach needed. So for the selection criteria, in case of there is some small dispenser machine of these days, like water sanitizer machines are there, and there need to be one sensor need to be there, like proximity IR sensor need to be there. So if I take the example with the selection criteria, the selection criteria can include the mechanical part and the sensor particularly. That the cost will definitely came as a criteria for each and every. Whenever we have some particular part need to be purchased, then cost will be always a criteria, but I'm not taking that part. But the criteria of sensor will be take the example, like if we wanted to integrate it with a simple approach, there could be the digital or ADC part could be there. So these can be the criteria, like what integration we want to have with our this particular part. In case the sensor have the long distance or long, like in a particular case of that water flow, water overhead water tank problem, then the sensor need to be integrated with the controller, either with the ADC part or need to be digital IO part. So these could be the criteria for the sensor particularly. And the second part is the mechanical. It will also came into the picture, because how the sensor will be integrated with the particular body or the product basically. So these will include the selection of the sensor. Like for example, if a few days back someone is discussing the same thing with me, that how we were, what sensor we should take for dispensing that sanitizer, automatic sensor, automatic sanitizer dispenser. So they chosen one sensor which is from the Vishay Electronics, and this is very small sensor. Very small IR sensor, but that cannot be implemented outside. Like we cannot a product make it into product directly. So we have to choose some sensor which is having its own body and that having some screw fitting, and that can be plastically fitted into some particular plastic part. So these sensor criteria, selection criteria always come to the picture. One particular part which I specifically wanted to mention here is if there is some specific requirement came or derived from the sensor, like if I say that in particular measurement devices, like in metering, or if some particular control measurement devices, if there is some sensors are working, like current sensors are there, so they come with some specifications, and they need to be meet some requirement for some particularly certification. So that will came directly approach to the what sensor we select. So there could be the plus minus 1% range of that sensor output, or sensor need to be keep into that particular range. Within that particular temperature range, there could be some interruptions. Also, sensor criteria will always derive from application requirement, mechanical requirements, and some specifically it will derive from the certification for which the application is designed. So definitely these will be the criteria, and cost will always the criteria which to meet the quality, where we lose the quality, and the cost will we should not lose the quality. So that will always the criteria and the last point. But in earlier we need to choose all these things firstly. In addition,
Hello. 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 Sir, I'm audible. Hello.
Yes. Yes, Dr. Naveen, you are audible. Please.
Thank you, Naresh, sir, for wonderful sharing your content. Because I was going through your slides, your topic was basically prototyping the embedded system. I am more interested in this particular topic because now I am planning for hybrid type of sensors for monitoring the airflow because I am working on inhaler incubation units. So I just want to verify whether I can go for the designing of some hybrid sensors for airflow measurement. Let me say my requirement is something around 5 square meters. So within that, I want to monitor my product and verify whether it is actually measuring the flow of the air or not. So is it some possibilities if you can throw light on it or if you can help me out?
Yeah, thanks for asking. So what I understand is you wanted to monitor the air quality basically here. If I get
No, sir.
the question correctly.
Airflow.
Air,
Airflow through a
so,
airflow
okay.
through a nozzle.
Okay.
Yeah.
Okay.
Within a distance of
So,
5 square
yeah.
meter, I want to just monitor it. Can I go for hybrids type of sensors?
When you say the hybrid kind of, what does it mean hybrid kind of?
Because
Can you please elaborate?
while monitoring the airflow, also I like to monitor the quality of the air in the environment also within a span of 5 square meters.
Okay. I think that the sensor which came, I think you are using some digital sensor here. What I understand from what you are saying, that these are the digital sensors, and there is a hybrid sensors are perfectly fine because usually there are a lot of good hybrid sensors available which fulfills your requirement, and definitely these are very good, and you can choose the Sensirian modules as well. So if you wanted to know any of the company names, so I have worked with that part as well. And there are hybrid modules are perfectly fine. There is nothing issue with these parts, and these are available. Hybrid sensors are mostly within digital sensors, so that you need not to do any analysis on the direct data, but the data will be available. But in case it is need to be used with some analysis and research part particularly, then I suggest that do not use them direct digital sensors, but instead of that you can use ADC sensors, because they will provide you the raw data and the algorithm can be written from your side. But that is also your requirement part. If you are wanted to work on the application part majorly, then the digital ones are very good because the noise will not be there. They will provide a very fine result to you. Direct result will be there, and hybrid sensor work very nice and perfect. But in case of ADC, the hybrid sensors are not very feasible things, or not very good things. But the discrete sensor, different sensors need to be used, so that there should be not any interface or any noise issues should not be there. So I suggest, as per your application, if you are more towards the application part, then you can use the digital ones and the hybrid ones. But in case you wanted to work directly on the data and the algorithm need to be designed from your side, then I suggest for early phases choose the ADC, and then on the later stages you can work on the data directly. That is my suggestion. I hope,
because sir, I am working on MUCOS, because I am working on MUCOS RTOS. So it will be possible, easy for me to integrate it on that platform. That is why I asked this.
Right. That will be easy. That there is no significant change with both of the things. That will be easy to integrate. Definitely. That will be easy.
Thank you, Naresh.
But before integration, I think you should choose the application.
Yeah. Thanks,
okay, thanks.
Thank you so much.
Naresh sir, please, your email and contact details not in last slide. Please share your contact number and email.
Right. Sure, sure. I'm just writing it onto the chat box. So
Yeah, Dr. Naveen, I think this selection of sensor is very important issue. See that we have to identify actual problem, like what the parameter we want to measure. So first of all, whatever that physical problem we are having, we have to identify that exactly what is the flow of air, like which type of sensor you are going for. And this is very important because the cost of sensor, that sensitivity of sensor, that workability, like in which particular environment you are going to place it. All these things, like there are biosensors are also available. So which can you implant in our body also. So different type of sensor they are having for one same particular parameter. You have hundreds of sensors available, and you have to identify what particular cost you are ready to pay for that. What is the exact resolution, or what is the exact sensitivity, what is the exact workability maybe required for some petroleum product or like that. So you have to identify whether you may be able to place that or not, what type of material it is having. So it's a really big area, and we have to identify that is the role of engineer. That is the optimum or the best possible solution we can come out with. So that is discretion of engineer also. So that's a really very nice question. We'll
because sir, thank you so much, sir. Because actually I'm working with Blackfin also on analog signal processors. Because today people are only talking about DSPs and all, but anyhow DSP will come only when analog inputs are there. So we are working on ASP, where the portable related to the batteries can be overruled by the moment of our expansion and contraction of our skin. We can charge our devices. So we are working on that. So in that particular scenario, also, I was working on those hybrid modules. And thanks, sir. Now you have given me another idea of biosensors to collaborate with those ASPs. So Blackfin is doing wonders, and we are hoping that within a span of 2 years or so, I will be coming up with one good product of ASPs into the market, which will be definitely overruling those battery-operated portability constraints. So I'm hoping for the best.
That's great. That's great. And you should provide me your contact number so that we can include your special lecture in any future FDPs.
For sure, sir. For sure. For sure, sir.
No. And that's a great service to the society. See, engineering is not earning money or just making, just acquiring some power or like that. It's the real product. What the facility you are creating for the society. That's very important. And rest of the things are byproduct only. So it's great to hear that you are working on such type of area, and definitely it's a very important area. We will try to include such type of lecture. So we should have some more questions. Participants, please come out with your, it should be more interactive. No questions? It's lunch, getting late for lunch. So first of all, I apologize because that was out of our control. That network issue initially, it was little bit mash up we had, and I apologize Naresh also, because he was having his writing tab and he was having a different sort of attitude that a very explanatory sort of lecture he was going to take, and definitely that initial problem would have changed that mood also. So, but finally we come to a good end, and we learned lot many things from Naresh. And thanks to all the participants that you were so patient. And you can understand this is Bikaner. We are in Bikaner and we are just quite near to Pakistan. It's 135 kilometers from here. So we are just taking care one end of India, and we are having we are short of resources, but still we are trying to do something good. So thanks to all the participants. We will meet just after 1 hour, 2:30. Thanks, Naresh. And thanks, especially thanks to Dr. Naveen Rathi, Dr. Momin, really Dr. Masood, who has made this session very interactive. The next session, our senior product developer, Pushpendra, he will be taking. So he will be taking that next session on that electronic circuit design. So how we can automate the system, how we can take the benefits of AutoCAD tools, and we can make some good designs, electronic circuit designs. And initially this third session will be on electronic design using AutoCAD tools. And 2 more sessions will be there tomorrow. That will be just integrating the system and what the different type of modules we are having. And finally, we make a particular product. And that product, you will see how we identify that what was the problem, what was the specifications, and how that problem was addressed by Pushpendra. And finally, he made a product. So thank you very much, all the participants, my friends, faculty members. See you at 1:30. Thank you. At 2:30. Thank you very much.
Thank you very much. Thank you. Thanks for joining.
Thank you, sir.
Sir, thank you, Naresh, sir. We'll meet somewhere in future.
Yeah, sure, definitely. I'm glad to meet you when you're available.